Hello and welcome to another Java video tutorial. In this tutorial we're going to have a look at very basic error handling in Java. Now the types of errors that I'm talking about are not syntax errors. They're not the errors that happen when we go to compile our program and we've typed something in incorrectly. They're not the types of errors that we're dealing with here. The types of errors that we're dealing with here are errors that happen when our program is running. So when the program is running and it encounters a situation that it doesn't know how to deal with, that is called a runtime error. And there's a special way in Java to handle that runtime error in a little bit more of a graceful way, because otherwise, if we didn't do that, our program would just crash on the user, and they just get some kind of error message on the screen. So that's the situation we want to avoid. And we're going to see how we can introduce a special type of construct in our Java programming languages to deal with these runtime errors in a more graceful way and hopefully allow the program to continue instead of crashing out on the user. So how are we going to do this? Well, we're going to have a look at one or two little example programs, and we're going to build these runtime errors into those example programs, and then we're going to look at how we can handle those runtime errors in a better way. Okay, so the very first one of these example programs that we're going to look at is this program here. I've already set up the class and the main method for this. The name of the program is called dividebyzero.java. Name of the class is called dividebyzero, and you can kind of guess what this program is going to do by its name. We're going to try and divide a number by zero. Now, we're not allowed to do that in programming languages because division by zero from a mathematical standpoint doesn't make sense. You can't divide by zero. So in order to show you that, what we will do is set up a couple of lines of code that will actually cause a division by zero, and then we can have a look at the error message that occurs when this program runs, and then we'll see how we can handle that a little bit better. So let's do the divide by zero code first of all. So I'm going to set up a variable int x, and I'm going to set that equal to 10. It doesn't really matter what number I give x, but I'm just going to set it equal to 10. And then I'm going to have another integer variable z, and I'm going to set z to 0. So x is 10, z is 0. And then I'm going to introduce another number, another integer number called or variable called or, and I'm going to set or equal to x divided by z. Okay, so this is the offending line of code. This is the line of code that's going to cause a problem because x is 10, z is 0, and we're going to try and divide 10 by 0, and we should get a runtime error that is caused by this division by 0. Okay, so we can't divide by 0. So that's going to cause a problem. And when the program encounters that line of code, it's going to crash. It's going to be running perfectly up to that point. It's going to execute this line of code, execute the next line of code. But when it gets to this line of code, it's going to crash out. It's going to bomb out because we have a division by 0. Now, to prove that, what I'll do is I'll put another line of code in after that. So we'll put a little message here, and I'll say system.out.println, and I'll say will not. Okay, all right. I'll just print out a message to say we are here. Okay, so that line of code, this one here, system.out.println, that line of code will not execute. The reason why that line of code won't execute is because we have an error that's going to happen on the line above the previous line of code, and that's going to cause a runtime error which will crash our program. And the reason is because, as we've said, it's a division by 0 error. And when the program is running and we encounter that line of code that causes the division by 0, the program doesn't know what to do, and it just can't continue because we haven't told it how to handle that error. So let's save it and let's compile it. Okay, so Java Java C divide by 0.java. So we're going to compile the code, and as you can see, we don't get any syntax, and we've no syntax errors in our code, so we don't get any compilation errors. So we haven't broken any syntax rules. Program compiles absolutely fine. There's no syntax error messages, or there's no syntax errors in the program. The error occurs when we go and we run the program. So I'm going to say Java and divide by 0, and when I run the program, we get an error message. And this is the error message that we get. Look, it says exception in thread main, java.lang.exception, arithmetic exception. And then it says by 0, okay? So what it's saying is there's an exception. An exception has happened. Something exceptional has happened when the program is running. The thing that happened was an arithmetic exception. So mathematically something went wrong in our program. And the type of message or the type of mathematical error that happened was a divide by 0. So this error message is actually telling us what went wrong in the program at runtime. But the program just finishes at that point. You'll notice this line of code never gets executed. The "we are here" never appears on the screen. Look, it's not there. We get that error message and the program just finishes. It never gets to that point in the code. So it abnormally finishes. It doesn't finish in the normal way. It doesn't just get to the last line of code and execute it and finish. It finishes in an abnormal way. And we want to avoid that. So how are we going to do that? Well, we can introduce something in our programs called a try and catch block. And try and catch blocks allow us to like trap an error, to catch an error, and then do something about that error. So the way we write a try and catch block is as follows. So we use the keyword try, and there's a try block. So a block of code is introduced at this point in the try. So this is the try block of code. So the block of code is signified by that open and close bracket. And for every try block, we need a catch block. Okay, so we're going to have the keyword catch and then a set of brackets. And we'll fill in those brackets in a second, but just leave them empty for the moment. And then there's another block of code associated with the catch. So we have an open bracket and a closed bracket associated with that as well. So we actually have two blocks of code now. We have a try block and we have a catch block. Okay, now the idea is that any code that we want to catch an error for should go into the try block. And if that code causes an error, then we get the opportunity to catch that runtime error in the catch block. Okay, so this is what's going to happen. We are going to copy a little calculation here, our divide by 0 calculation, and we're going to put it into the try block. Let's put it in here. Okay, so those 3 lines of code that caused the divide by 0, especially this line of code, that's actually the line of code that causes the divide by 0 problem or runtime error. That's going to go into the try block. And in the catch block, what are we going to do in here? Well, this gives us an opportunity to catch that error. So let's look at the error that actually happens. The error that actually happens is called an arithmetic exception. So what I'm going to do is I'm going to catch that error. So I'm going to copy that error as it's spelled there, arithmetic exception. I'm going to copy that and I'm going to put that in the brackets of the catch block. So I'm going to paste that in there. So we have catch arithmetic exception. That's the type of exception that we want to be able to catch, the type of error that we're interested in catching. Now, as well as saying the type of error that we want to catch, we also have kind of like a parameter. This is almost like a formal parameter when we use methods. So the type of error is an arithmetic exception, and then this parameter here, this E parameter is, I could call it anything, it doesn't have to be called E, but that's the error object, if you like, that we're going to use in this catch block. And I'll show you what I mean by that. Now, there are lots of things that we can do with exceptions in Java. And as I said, this tutorial, we don't have time to go into it in very much detail. That would require a whole other lesson. But we're just going to, really kind of just tip of the iceberg stuff here. So what we can do with that error message, or that error that we've now caught, is that we can say something like e.print stack trace. And what that will do is that will tell us what has happened in our program up to and when that runtime error actually took place. So this is useful for trying to track down the error. If the error happens and you're unsure why it happens, this is a very useful thing to do, to be able to try and track that error down, because it tries to tell you what happened in the program leading up to when that runtime error actually happened. So what we'll do is we will now compile this new piece of code, the try and catch block. So let's just review what we've done. We have put the offending code inside a try block, and then we have an associated catch block. For every try block, there must be an associated catch block. And in our catch block, what we've done is we've caught the particular exception that we're interested in. We have this little exception variable here called E, and then we're saying e.print stack trace. So that will show us what happened in the lead up to that particular runtime error. And then, of course, we have this other line of code. We are here, and hopefully we'll see now that that line of code should execute, because we've actually trapped the error and done something with it. So let's compile this code, or let's save the code, and we'll go over and we'll recompile. So javac and divide by 0.java. So we'll compile it. Again, there's no syntax errors, so let's run the program. Divide by 0, and look at what happens. We get our error. We still get the arithmetic exception, divide by 0 error, but we also get this line of code that executes. We are here. So this system.out.println line of code has actually executed. So you can see our program has finished as it normally would. It's trapped the error, it's dealt with the error, but it has continued on and actually executed the very last line of code in the program and finished in a normal way. So it has handled the error but still continued on as it normally would to finish and execute the very last line of code in our program. So that's a good thing, right? I mean, that means that the program has actually finished and has finished in a normal way. Now, what about this error message that we have here? This is a bit cryptic, and for us as programmers, of course, it's very useful, because now we can track down and we can understand why that runtime error actually happened. But from an end user point of view, this is not very useful. The end user is not going to understand why that happened. So we can do something else. We can print our own message here instead of e.stacktrace. So I'll comment that line of code out just for a second, and I'll put in our own error message just to show you that we can do that. So we could say system.out.println, and I could say divide by 0 error or something like that, okay? And we can save that and recompile. So let's recompile our program over here in the terminal window. Let's run it again, and now you'll see that we get our own error message instead of that rather cryptic one that appears. So you can see we get the error message divide by 0 error, and then the program continues on and runs and finishes as it normally would. Now, do you have to output an error message? Well, actually, no, you don't. So if we don't do anything inside the catch block, for example, if I comment out that line of code, that last line of code that we put in, the system.out.println. So effectively in this catch block, we're not actually doing anything. We're catching the error, but we're not really doing anything with it. We're kind of just ignoring the error. What would happen in that case? Well, let's compile and see what happens. So let's save that and we'll recompile out here. Let me just clear my window here for a minute. So compile javac.divide by 0.java. Still no syntax errors. And let's run the program again, java divide by 0. And now you can see, well, we don't get any error messages appearing on the screen. Does that mean that an error hasn't occurred? No, it doesn't mean that an error hasn't occurred. It means that an error has occurred. We have caught that error. We have handled that error. And we've decided to just ignore that error. We've decided to do nothing with it. We've decided to give no messages. We've decided to not do anything different. We've just decided to trap the error, handle the error, and do nothing and continue on. And as you can see, we still get our message that says we are here, which means that this very last line of code in the program has executed and the program has exited in a normal way. So you can see how this try and catch block allows us to capture an error, and it allows us to handle that error in a way that will still allow the program to continue on and exit as normal, rather than crashing out and giving the user some kind of cryptic error message and just stopping dead in its tracks and not continuing out to the end of the program. So you can see this is very useful, and obviously there's lots of situations that we encounter this type of runtime error message in. For example, when we go and have a look at using file input and output, this is going to become very important to us because, you know, there are lots of situations. For example, if we try and read information from a file that doesn't exist, or if we try and create a file and for some reason we can't create that file on the system, then we may get errors and we'll have to try and handle those errors. There's another situation that you may have come across where a runtime error happens, and that is when we deal with arrays. So the next little example is going to show you how a runtime error can happen when we use arrays, and I'll also introduce a try and catch block that shows you how you might be able to handle that situation. Now this situation is a little bit different because you should first of all make sure that you don't write any code that causes any problems with arrays. And this particular example is a little bit kind of manufactured in a way, just to illustrate another type of runtime error and show you how the try and catch block can handle that. But above all else, when you're dealing with arrays, just make sure that you write really solid code that isn't going to cause any of these types of errors that we'll see in a minute. That's the best approach. And in general, we wouldn't really use try and catch blocks in this situation. As I said, it's a bit of a manufactured example, but again, it's just an illustration of how we can use try and catch blocks. Okay, so I have another program here that I'm going to write, and this is going to be called class array index error. Array index error, yeah, that's right, that's what it's going to be called. Array index error. And I'm going to have public static, let's spell static correctly, public static void main string args. And okay, what are we going to have in this little example program? Well, I'm going to create an array. So I'm going to have int, I'm going to call my array list, and I just want to put some numbers straight into the array. So I'm just going to use the kind of list notation to initialize the array with some values. I'm going to initialize it with the values 1, 2, 3, 4. I don't need to put a lot of values in it because it's just a simple little example. Now, of course, when I create an array like that with 4 values in it, 1, 2, 3, 4, I have an array that contains 4 items. So the indexes start at 0. So I have an item at index 0, an item at index 1, an item at index 2, and an item at index 3. Okay, so because it's a 0-based array, our indices go from 0 to 3. So for example, I can say I can say list 0 equal to, well, I could change the value if I wanted. I could say 100. I could say list 1 equals 200. Equals 200. I could say, and I better spell list correctly there as well. I could say list index 2 equals 300, and that would be absolutely fine. So I could save that little piece of code, and I could go over here to my terminal window, and I'll compile that. And we get an error message. Illegal initializer for int. Oh, of course, look, I forgot my square brackets on the list. Look, I said int and I had a list and no square brackets, so of course that wasn't an array, right? So I'll save that, and let's try and recompile again. Okay, and we compile, no syntax errors, that's great. And then we're going to run the program. So Java array index error, going to run the program. It's not going to do anything, but I just want to show you that there are no runtime errors. Okay, so I ran the program, didn't do anything, but we don't do anything. We just initialize the array and change some of the values in the array, right? Let's put a little system out message in here. In fact, let's just kind of print the first item in the array. Okay, so let's say system, or we could print them all. Why don't we print them all? System.out.print f. I'm going to use a printf, and let's print the first item in the array. Let's use a %d placeholder, and then I'll put a comma and %d. There's 4 values, so let's do 4 %ds, and then I need a new line, and then I want to print out, what do I want to print out? Well, I want to print out list 0, list 1, list 2, and then the last item in the array. Well, what's the last item in the array? That's at index 3, right? Okay, so let's save that. Again, let's go over here. Let's recompile our program. No syntax errors, so I'm going to run the program, and we get our output. Okay, 100, 200, 300, and 4. So remember, I started off with 1, 2, 3, 4, and then I reset the first item in the array to 100, reset the second item in the array to 200, reset the third item in the array to 300. So I get 100, 200, 300, and the original value 4 is still there. Okay, absolutely fine. No problems with this so far. But what I'm going to do now is I'm going to introduce an error. What about if I said list, and I'm going to say list 4 equals 400? What will happen? Well, do I have an index 4 in my list array? Well, no, I don't. I have index 0. The item at index 0 is 1. The item at index 1 is 2. The item at index the item at index 1 is 2, the item at index 2 is 3, and so on. So I have the last index in my array is index 3. And when I say list 4 equals 400, that's going to cause a problem, right? So I'm going to save this. I'm going to recompile. So no syntax errors, but when I run the program, this is what happens. I get an error. And have a look at the error. Well, it's an exception, so it's a runtime exception. It's an error that happened when the program was executing, when the program was running. And what's the type of error? Well, it's an array index out of bounds exception. You can see the name of the error here, array index out of bounds. Okay. And what that's saying to me is that this error has occurred. You are using an array. You used an index in the array that is out of bounds, an invalid index in the array. And I did, because our indices in our array go from 0 to 3. and I tried to use index 4, which doesn't exist. There's no item in my array at index 4. So that's a problem. What happens when I do that is I get a runtime error. The program doesn't know how to handle, or the program isn't built in a way to handle that error. And it doesn't know what to do at runtime, and it just fails. Okay, so it doesn't continue. You'll notice I don't get any output. The array isn't output in any way here. I just get this error message and the program just crashes. So I'd like to be able to handle that. I'd like to be able to deal with that error. So what do? Well, I put in a try and catch block. So I'm going to say try, and I'm going to have a block, and I'm going to have catch, and I'm going to have a set of brackets, and I'm going to have a block of code for the catch. Okay, what am I going to catch in this here? Well, I'm going to catch this error, this array index out of bounds error. So I'm actually just going to copy that, and I'm going to put that in here in the catch. So it's the name of the runtime error that I'm catching is array index out of bounds exception. Long-winded, but there it is. And the name of the variable that I'm going to give, that I'm going to use to trap that error again, is e, just like I did in the divide by 0 example. And I'm going to take my code that I'm using, and I'm dealing with the array. I'm going to take that code and copy it and put it into the try and catch block. So I'm going to put the code into the try block, and then I'm going to catch the error in the catch block. So I'll do the same as before. I'll just say e.print stack trace. So we'll do that first, and then we'll see that we get the error message and everything still continues on absolutely fine once we've caught the error, and then we'll maybe output some of our own, or one of our own error messages as well. So okay, let's save that, and let's go over here and recompile. Oh, I've got an error message. What's happening here? Can't find symbol. Oh yes, of course. So what's happening here is I have declared my array inside the try block. So it's a local variable inside the try block. What I'm going to do is I'm going to take the declaration of the array out of the try block, and I'm going to put it above here in the main. Okay, so I'm going to declare my array first, and then I'm going to have the code that accesses that array in the try block. Okay, let's save that and compile it. Should be okay now. Yeah, absolutely fine. No syntax errors. And let's run the program now. Okay, so let's have a look at what's happening here. We still get the error message. Okay, we still get the array index out of bounds error message. But also our program continues. We get the output. Okay, we get the array output here after the error message. So what is that telling us? Well, that's telling us that okay, the error still happened, the runtime error still happened in our program, but we have caught the error in a graceful way, and we have done the stack trace. We've printed out the stack trace to print the error message, so that's useful to us as the programmer. We can figure out what's after happening, what's gone wrong. And then the program continues on because this system out line of code actually gets executed. And we know that it gets executed because if we have a look at the output, we can see that the numbers in the array get output. Okay, so the program, even though the runtime error happened, has continued on. It's handled and dealt with that error, and it's still exited in a normal way. That last line of code still got executed, and the program finished. And of course, we could, if we wanted to, print our own error message here again. So we could say system.out.println, and we could say array index error or something like that if we wanted to. Let's recompile the program again. Let's clear the window up a little bit. So compile the program, and let's run the program, and we get our error message. So we get array index error. Okay, so we have trapped the error and handled the error, and we've given an error message which is output to the screen, array index error, and then the program continues on. So this line of code gets executed and we see the array output to the screen there. Okay, and once again, just to kind of illustrate the point, do we have to print an error message? Are we forced to print an error message? No, we don't have to. Again, I could comment out those 2 lines of code in the catch block. So we are catching the error, we're handling the error, but then we decide not to do anything with that error. So we don't have to have anything inside that catch block. We could leave it empty. And if we leave it empty, of course, save that and recompile over here again and run the program again. And as you can see, now we don't get any error message printed to the screen. The array still gets printed to the screen. So what has happened is that line of code that causes that runtime error has effectively just been ignored. We have caught the error is still happening in the program and it's being trapped and caught, but we're deciding not to do anything with that error. Now, is that a good thing? Probably not, because that means there's an error in your code that you're unaware of. Okay, but again, this is just to illustrate how the try and catch block works. Okay, there are good programming practices that we need to put in place in order to use try and catch blocks effectively, which we'll deal with later on. But for the moment, it's just really to see how the mechanics of the try and catch block work. And I think these 2 little examples illustrate that and show you how the try and catch blocks can be used to try and catch runtime errors in our programs and stop the programs from exiting abnormally, stop the programs from crashing out, and it allows us to deal with those runtime errors in a kind of more graceful way in order to let the program finish and exit out in a normal way. So if this was of any use to you, please give the video a thumbs up. If you're interested in learning more, please subscribe to the channel. I'll have lots more videos coming up. I'll be extending on some of the ideas in this video, and we'll be continuing on building our little menu system, and we'll actually be incorporating some of these runtime error handling techniques into our little menu system that we're developing. So you know, please give me some feedback, leave some comments down below, give the video a thumbs up, hit the bell icon, and make sure you don't miss any more videos. So thanks a lot for tuning in, and I'll see you next time.